All right, first thing is, any questions from homework stuff? Yes, and then I'll go this way.
Number 23 on 9.2.
9.2?
Yeah.
Yeah, that's the word problems I'm talking about. So we're going to get into that today. Yeah. Yes?
Number 12 on 9.1.
All right, so what happened with that one? All right. Let me do this. Let me give you guys, let me see if you guys can handle this. One side of this has 9.1, an example from 9.1. The other side is going to freak you the flip out. It's from 9.3. Don't look at that side. Don't look at this. Look at the side 9.1. Okay? You have it sit next to you while you do homework. It kind of reminds you about the steps to take to solve those equations. All right? This side we're going to reference later when we get to 9.3. And then we'll start that problem up, Sarah. All right. So again, this is just a nice little discussion about a problem, and it explains why the steps are the way they are. This little worked out problem. This side is very colorful. Don't worry about it yet. This side, okay. So this problem, let me write it down up here. What you want to do for damn sure on these problems is like triple check after you write them down, right? Because if you write something a plus instead of a minus, you're never going to get the right answer. Does that make sense? So if you do that kind of thing on a quiz or a test, I might take a point or something off at the beginning, but as long as you do everything else after that correctly, you'll get most of the points. Because that's the concept. You make one little mistake about transcribing it incorrectly. Okay. Does that make sense? So just be careful. Though it really sucks to start getting answers like 27 over 23, and you're like, oh, God. All right. So let's see. Which again, this is kind of funny how everything we've done so far is the same letter we kill, but which letter is kind of set up to die better? And Y is kind of set up to die. Not always. Again, good Lord, hopefully nobody's taking that to heart to be like, I always have to do Y first. No. It's just because of the problems we looked at, it just happened to be Y we did. Y makes the most sense because this is the opposite sign of this, and it's the opposite sign of this. These two I don't have to do anything to make the Y's die. And this one I can do one simple thing to make the Y's die. All right? Is it wrong if you kill the X's? No. Is it wrong if you kill the Z's? No. It's just the Y's are sort of set up a little bit better to die. Okay? So what's one way to kill a Y? Yeah, what's the most direct way to kill a Y?
Opposites.
No, come on. Isn't there a way to just kill it? No, you don't have to change anything.
No,
1 and 3, right? 1 and 3. If you add those, Y's gone, right? Okay. So what do you get when you add 1 and 3? Where's my man at? He's not paying attention. You get 4. Actually, you do get 4. You get the fourth equation. Well, what do you get? You get 3x.
Cancel out. 2z.
Minus 2z. Negative 10. You see how there's so many little places to make little mistakes. The little mistakes are just going to throw the whole thing off. So you kind of want to go a little slow through. Don't say 4 minus 14 is negative 18 or something like that. You do that, you're going to start getting weird answers. And now I just got to kill y one more time. So like you guys started to tell me, you can use these two if what?
3 times.
Multiply 3 by 3. I love it. So if you just leave 2 the way it is, well, you take 3 and multiply by 3.
6x minus 3y.
Negative
43.
Negative 42. Alright, and again, you guys don't get lost in the details. Details don't matter here. I know you can add like terms. The bigger idea is why the hell did I multiply that by 3? Why the hell am I doing what I'm doing? Did I have to do what I did? No. Pick a letter. Kill it twice. Which letter? I don't care. Whichever letter you can see to make it happen, you do that. Cool. So if I do this, I'll get equation number 5.
8x.
8x. Die. 4z equals
Negative 36.
negative 36. Notice how you can divide this by 4. Let me see if you guys pick up on this. I don't want to divide by 4. I want to divide by 2. Why? Right? So you can start to be smart about what you want to have happen next. Or you could double this. You could double this one and make it negative 4z there. It doesn't matter. The math doesn't care because it's going to reduce at the end anyway. So it doesn't matter if you multiply something up, it's going to reduce down to what you would have gotten anyway. Is everybody semi with me? So we got this better equation, this better equation, and together they kick ass because they both have x and z in them. Sarah, did you happen to kill the y's first, or
No, I
what did you kill?
No, I did the Z's.
Yeah, the z's will work too.
Yes.
You'd have to multiply one of these by a negative, though, and when you have to multiply by negative, that's another place where we make mistakes easy, right? Yeah. So you should be able to handle it, but even me, I'm not going to pick a way that I have to use a negative because that's so easy to forget to change somebody's sign, right? Like from Virgo to Libra, no, from positive to negative, and then the whole thing goes to shit. That's all it takes. Okay, maybe. I hear voices. Hopefully other people hear them too. All right. Anything else from homework stuff? Is that far enough? Yes.
34, please?
In section 9.1?
Yeah.
Oh, okay, good. All right. What do you guys think? We saw one that sort of was like this. I got you pointing way too far over. Oh, that'll work. 34 looks freaky. And normally the way these things look freaky is they already have some stuff that's missing. So each of these is already missing a letter, but why collectively do they suck? Is there another L and M equation? Is there another M and shit. So collectively they sort of suck. But I don't know if you remember the one we did that was missing stuff as an example.
Like for one, you just subtract L, and then solve for N, and then solve for N, and then plug it into number
Yes, cool. I love it. So one way to do this is you could solve this for M and this for N, and then replace, because then you'd have M in terms of L, and you'd have N in terms of L, so then you would make an equation that only had L's in it. That's the first thing I look to do if I already have a few equations missing something. So if I solve this for m, how would I do that? Subtract L. So I get m equals 7 minus L. Become an L. L. And if I solve this for n equals 5 minus 4L. I like it. So then you can put this here and this there. Won't you have an equation that just has L's in it now? Did I have to solve? I could have solved this. But why does it make sense to do those? If I solve this for L and this for L, I'm going to have to make fractions. Do you guys see that? I have to divide by 4. So this m and this n they're the nicest ones up there. Is that the only way to do this problem? No. Is that the quickest way to do this problem? Yes. It's just like somebody killed a letter, killed a different letter, killed even the last letter. They just went crazy with killing. They just sort of focused on killing one letter twice, right? So now we're trying to clean up the mess. That's why we do this, what feels like a very different way. How are you guys feeling about that? Is that? All right, I got 1 thumbs up, and the rest of you, 2, no way, 3, holy shit, and the rest of you are like, I will not let you know.
So just plug in and that's the answer.
Yeah, well, I mean, if you plug those in, you'll get 3 times m. What's m? 7 minus L. Plus 2 times n. So I'm rewriting equation 2 here. And what's n? 5 minus 4L. Equals 9. Can you solve that for L? L, yes. Yes, you can. So you do it. Once you know L, what kicks ass about that? Once you know L, m is 7 minus L. So I know m. Once I know L, n is 5 minus 4. And I know both the other dudes because they're both dependent on L. It kicks ass. So when you're missing letters, that feels like a good thing. Because that's your whole purpose, is to kill some letters. But if they didn't kill the right letters, it actually kind of... But at the same time, it should make sense there's a quicker way to do the problem then. Because you're already missing some variables, which is the first thing I'm worried about is let's kill some variables, right? And you're all like, I like that phrase. Kill those things. Okay? All right, baby. Okay. So that's a good one to ask about. That's one of those freaky ones. That's why I definitely want to make sure we did that one in the green book. Give you an idea of what to try. What would have been great is if this was L and N, and this is L and N, you could just use those two and kill L or N, you know? So, do you guys see what I'm saying? So if there was the right variables missing, it's like somebody did some work for you already. This one, shit, they didn't quite make it line up. But then I could do this. That's awesome. That's awesome sauce. Let me show you one other interesting flexibility that you have that you very often aren't shown. Let's say I have an equation that looks like 2x plus 5y minus z equals 11. And then somewhere else I have an equation 5y minus z equals, what you got, I don't know, 3. So what is 5y minus z? What is 5y minus z? 3. Do you see 5y minus z? So you could put a 3 in place of the whole damn thing. This is something that we sometimes don't even realize we're allowed to do. What is 5y minus z? It is 3. Oh, shit. So that's another little thing that you can look for that might sometimes happen. I'm not saying it's going to happen everywhere or at all. But it's another little thing to realize. Substitution doesn't just mean A is 2 and put a 2 in for A. Whatever I know, if I see it, I can replace it with what I know about it. Whatever it is. That's beautiful. Okay, maybe. All right, anything else? Homework stuff? Yes?
Number 15.
That one, I will tell you, it should come out to be no solution.
Right. It's just y equals numbers.
Yes, yeah, I think that's the one where you get y equals 7 and y equals 2, and you're like,
Number 15?
Number 15, yes. Number 15 should come out weird, and it has no solution. So another way, I mean, that's a way we haven't talked about. If you get y equals 3 and y equals -5 in the same problem, can that happen? No, y can't be two different things at once for a solution. No, so no solution. That means y must be 3 and y must be -5. How the hell can that happen? I feel like it's... Anything else? Homework stuff? Okay. All right. So like it's a little review. I like it. So we can jump into, we're going to do section 9.2, and then we're going to get into section 9.3. 9.2 is the word problem section. Watch out. Let's see, did they give us some of these? Let's try some of these in here. I'll start this guy up, but let me do a nice straight up problem. So very often these are easier to set up than your regular word problems. What this should do, I mean, let's say I buy, oh God, I buy 5 apples, 2 bananas, and a cookie. Right? And let's say it costs me, let's make it easier on yourself, Jeff. Sure. All right. It costs, oh crap. Yeah. 20 bucks.
How many cookies?
5 apples, 2 bananas, and 1 big ass cookie.
That's easy. 6.
I don't know, man. Leave me alone. All right, magic apples.
Okay.
2 giant bananas, and a triple fudge cookie sandwich. All right, and that costs 20 bucks. Can you guys already imagine an equation to set up? Do you see how it sort of sets itself up? Can you see that? What would the equation be? 5a 2b plus c equals 20. Now, and then I would follow it up with, what if and Sam buys 3 apples and 4 bananas and 2 cookies for so much money? That would be another A, B, C. And then Mary buys no apples and 3 bananas. Yeah, and that would be a third equation, wouldn't it? And then once you get the equation set up, how do you solve it? The way you did in 9.1, right? Do you guys see what I'm saying? So most of these are related to this idea. They set themselves up almost. So let's look at a couple that are a little bit more interesting, but not crazy. Thank you. Holy crap. There you go, buddy. Zoom out. Okay. All right. This is page 67. I don't know why. They do section 9.3 before 9.2, but forget that. Now, again, there are some elements on this problem that you have to kind of know going in. But look at the very first thing it tells me. The measure of angle B is twice the measure of angle A. Can you write an equation for that? The measure of B is twice.
B equals 2A.
Yeah. Right? B equals 2A. Awesome. That's nowhere near a train leaves Wyoming going north at 50 miles an hour. That's not nearly the same level of hatred for that. What about the second thing? The measure angle C is 80 more than that of A. Yeah, let me write this just because I'm crazy. Now, do they tell me how many things do I not know? 3, A, B, and C, right? But how much information does it seem as if they've told me? 2 things, but there's a third thing that I'm supposed to just know on my own. This is a triangle we're talking about. A plus B plus C equals 180. Now this specific one is almost too nice. Does anybody see? Do you see how this is missing a C, this is missing a B? So there should be a quicker way to do it than the standard way. Does anybody see something? Maybe related to one way. Yeah, I know B is 2A. Let me put that there. I know C is A plus 80. Let me put that there. And then this equation is only going to have A in it. So do it. Finish that. Finish it.